Good morning, dear student. In today's lecture, we will discuss the next practical of our course, that is determination of aluminium from alum. So, what is this alum? So, let us discuss some important points regarding to this alum. So, we are very much familiar with this alum. It is most widely double salts. It is most widely double salts with general formula. It is a double salts with general formula capital AM SO4 twice having 12 water molecule. Again, if you consider this A, it is your monovalent, means it is in plus one oxidation state. Monovalent cation A is your monovalent cation such as potassium or ammonium. And what is this M? This M, it is your trivalent metal such as aluminium, or you can write here, such as aluminium, it is in plus 3, or chromium, it is in plus 3. So we should remember its formula. Alum, it is the double salt in which one is monovalent cation, another is trivalent metal ion. So let us discuss the determination of alum or determination of aluminium from the alum. So if you consider again the direct determination of this aluminium, calcium, magnesium is not possible, or we can say that it is difficult. So you should remember that is direct titration of aluminium, calcium, magnesium is difficult. So why the direct titration of this metal ion, aluminium, calcium and magnesium is difficult? Because whatever the complex which is formed, so they can determine by complexometry titration. So whatever the complex they forms very slowly, complex forms too slowly, so this is the one reason. Second, the metal precipitate out of solution. So there is a chances of metal precipitation or metal precipitate out of solution. So there is a chances of precipitation of metal in a solution, and therefore we cannot get the perfect endpoint. Another reason is that the suitable indicator is not available for direct determination. So these are the certain points, that is whatever the complex form, it is the rate of complex formation is very slow. Again, sometimes metal precipitate out from the solution. We can use the solution for titration in which the metal is precipitated out and the suitable indicator is not available. And therefore, for the determination of aluminium, from the alum, we can use again the back titration. So in this case, you have to avoid such a difficulty, you have to use the back titration. So we are very much familiar with this back titration. So for determination of aluminium from alum, by the back titration, we can use a solution that is EDTA, ethylene diamine tetraacetic acid solution. So we are very much familiar with this EDTA. For complexometry titration, it is agent, chelating agent is used, ethylene diamine tetraacetic acid. Due to the solubility, due to the less solubility, sometimes disodium salt of EDTA is also used. So For this back titration, you have to use EDTA. So EDTA is added, and the excess EDTA is back titrated with zinc sulfate solution, and the endpoint is determined by using erichrome black tea indicator. So for this back titration, you have to use EDTA, and then you have to detect the endpoint by using EBT indicator. EBT indicator. So we are very much familiar with this EDTA. EDTA, it is known as ethylene diamine tetraacetic acid. It is an hexadentate ligand. It is an hexadentate ligand. Normally, this EDTA, if you consider this EDTA or its full form, ethylene diamine tetraacetic acid, it is a hexadentate ligand. Hexadentate ligand. Second, if you consider it is a tetraprotic, so it contains 4 acidic proton, tetraprotic. Then it is represented as H4Y. All these protons are ionizable. All protons are ionizable to form anionic Y4 minus ion, and these Y4 minus ions interact with your metal ion to form a octahedral complex. Generally, this EDTA it will react with metal ion in 1:1 ratio. So this is very important point, you should remember. So whatever the metal ion is there, this EDTA it will react with 1:1 ratio, means for one metal atom, one EDTA molecule is required. So in this case we determine the aluminium, but the complex is formed, it is octahedral, because for one metal atom, that is aluminium, is considered as single metal atom, we required one EDTA molecule, and EDTA is a hexadentate ligand, therefore a octahedral complex is formed. So if we consider the structure, that is ethylene diamine tetraacetic acid, it is NCS2 N having CS2 C double bond O minus. So these protons are ionizable. Again here CS2 C double bond O minus, CS2 C double bond O minus, and these 2 nitrogen. So 4 oxygen and 2 nitrogen, it will binds with your metal atom such as aluminium. So if you consider here aluminium, and a octahedral complex is formed in which 2 are nitrogen. So in this case there is a 2 nitrogen and remaining are oxygen. So this nitrogen, so it is attached to this CS2, it is attached to this CS2, and this is attached to nitrogen. Again this nitrogen, it is attached to 2 CS2 C double bond O group. So CS2 C double bond O, and this oxygen, again this nitrogen, CS2 C double bond O, and this oxygen. Similarly this also CS2 double bond O, and this oxygen, again CS2 double bond O, and this oxygen. So this is your aluminium EDTA complex. Aluminium EDTA complex, octahedral aluminium EDTA complex. So we are not considering the charge, okay, just the octahedral complex is formed. So let us discuss the procedure for determination of aluminium from alum. So why use EDTA? In complexometry we can use EDTA. So this is a back titration for determination of aluminium. Okay, so if you consider we required a chemicals for determination of aluminium, so we required 0.01 molar EDTA solution, 0.01 molar EDTA solution. Then we required 0.01 molar zinc sulfate solution. Again we required dilute ammonia, dilute NH3, and then we required erichrome black tea as a indicator. Again, you have to take. So let us discuss dissolution procedure. So dissolution, it is very simple. So you have to take alum sample, dissolve in water. Sometimes this alum, it is not completely dissolved in water, so you have to dissolve in hot water. If it is not dissolved in hot water, then you have to use dilute acid. So dissolution, you have to use water, hot water. In different cases, you have to use dilute acid. Dilute acid for dissolution. Generally, hot water, it is used for dissolution of this alum, and then after dissolution, you have to dilute to 100 ml or 250 ml. So you have to make a volume, dilute to 100 ml or 200 ml, and then the procedure. So let us discuss the procedure. The procedure is very simple. You have to take diluted solution. For example, you have to take 25 ml diluted solution of alum, 25 ml diluted solution of alum. Then you have to add, so this is your back titration. So you have to initially add 30 ml 0.01 molar EDTA solution, and then for complete complexation, that is, when EDTA is added, aluminium forms complex with this EDTA, and for complete complexation, complex formation, for complete complex formation, you have to boil the solution for few minutes. 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 Then cool at room temperature. Cool at room temperature. Then you have to add ammonia to maintain the pH of the solution. Add ammonia to maintain pH, and then you have to add 5 drops of EBT indicator. EBT indicator, erichrome black tea as a indicator, and titrate this solution. So you have to titrate with 0.01 molar zinc sulfate solution until we get the end point, that is the blue color is changes. The blue color is changes to wine red. So this is your end point. Again, we already discussed that whenever you have to use EDTA, it will forms complex with 1:1 ratio. Therefore, for calculation, you can write 1000 ml 1 molar EDTA, which is equal to the molecular weight of EDTA. So for calculation, we can write 1000 ml 1 molar EDTA is equal to the weight of aluminium, that is 26.98 gram, and therefore we can write, if you consider y minus x. So what is your y? Y is your we can say that y is your initial volume of your EDTA. Okay, initial volume, and x is your the titration reading, that is you have to titrate this solution, excess EDTA solution, with zinc sulfate solution. So initially you have to take 30 ml EDTA solution, and whatever the reading after titration with zinc sulfate, that is your xml. Okay, initial EDTA, and this is after titration. After titration with zinc sulfate. So you have to take the difference and of 0.01 molar EDTA is equal to how much. And then you can find out the amount for 25 ml, and then finally find out for 250 ml, and then for whatever the weight you have to take. So this is very simple method for determination of aluminium from alum. So you should keep in mind, whenever you have to determine aluminium, calcium and magnesium, So you cannot use direct titration method. So for that purpose you have to use back titration. And for complexometry, uh, I have to use EDTA, ethylene diamine tetracetic acid, as a chelating agent or complexing agent. So it will forms a complex with any metal ion with 1:1 ratio, and therefore for determination of aluminium you have to use back titration with the help of EDTA solution. So this is all about the determination of aluminium from alum. In next lecture we will discuss another practical and another procedure for the determination. Thank you.